Hello. Today we're going to talk about 9.3 geometric sequences. So it's still sequences, so we're looking at a pattern. So look at this pattern. Hopefully you notice that this one is multiplying. Okay, that's a geometric sequence when you're multiplying by something. So let's derive the formula. To go from 3 to 6, we did 3 times 2. To go from 6 to 12, we multiplied by another 2. So we had 3 times 2 times 2, right? Well, how can we write 2 times 2? 2 squared. To go from 12 to 24, we're going to multiply by another 2. Well, 2 squared times 2 is just 2 cubed. So, well, and also, hold on, what's another way of writing 1? 2 to the 0. So notice our exponents are what's changing here. Everything else can be the same, right, if we think of that as a 2. Oh, I'm trying. Okay. So, let's see. To do the nth term, okay, all we would have to do is take 3 times 2. All right, in case you can't see it, the first term was raised to the 0, the second term raised to 1, third term to 2. So, to go from n, we would raise it to n minus 1. So, 3 would be considered our first term. So in this sequence, a1 is 3, and our ratio, what we're multiplying every single time, is 2. And we use this general formula. Okay? All right, so let's identify the pattern. So for number 1, notice we are multiplying by 4. So times 4 times 4, right? So the next two terms would be, what is that? 128, 256, then 512, then 1024. For the second example, notice we're going from 81 to 27, so we are dividing by 3 every single time. So how do we write that as an R? All right, we wouldn't say we're multiplying by 3, okay? What you would say, instead of saying divide by 3, we would say multiply, so multiply by 1/3. So that would be your R. Don't write it this way. Okay, I don't want to okay. So for this one, R is 1/3. So to go from 9 to the next term, we multiply by 1/3. So we would get 3 and then 1. Okay, write the first 6 terms of the geometric sequence. So you got your first term is 4. So just keep multiplying by 3, right? That's what you want to do. So the next term would be 12, then 36, then 108, 324, and 972. So this is the first 6 terms, right? This was a gimme. Okay, all right, don't want to miss that one. And your formula, in case you were curious, would just be 4 times our ratio, which is 3, to the n minus 1. All right, so the next one, all right, we would have, let's see, 125 multiplied by -2/5. We should get -50, then +20, -8, and then I would just leave it as fractions. No sense in making it crazy or ugly looking, right? Just do a simple fraction. That's what I would do anyway. And so our sequence, I know it didn't ask for it, but if we wanted to find any term, you would do 125 times -2/5, and then that whole fraction raised to n minus 1. Okay, just trying to get you comfortable with the formula. All right, so let's actually find the formulas for these four. For the first one, let's see. If we want to know what R is, you take one term and kind of go in reverse, right? So, well, because think about it. If we do 2 times the ratio, we should get -8. So to get the ratio, we just do -8 divided by 2. So take any term and divide by the term in front of it, and that'll get you the ratio. So our ratio here is -4. So our nth term is 2 times -4 to the n minus 1. All right, for number 6, to get the ratio, take one term and divide it by the 1 in front of it. So 20 over 25, which is 4/5. So our formula is 25 times 4/5 raised to n minus 1. Number 7, your ratio is -60 over 80, which is -3/4. So your formula is just this. Perfect. Number 8, get your ratio. Doesn't matter which terms you pick, you just look at the same answer no matter what, as long as it's a geometric sequence. So the formula here is just 400 times 1/4 to the n minus 1. Oh, I guess I should be circling these. I don't know, habit, I can't do it halfway. Okay, better. Now let's utilize that formula. So now we want to find the 7th term of a geometric sequence. Well, to find the ratio first, you do -8 divided by 2, so we get -4. So our generic formula is nth term equals 2 times -4 to the n minus 1. And we want to find a sub 7, so a sub 7, so the 7th term is 2 times -4 to the 7 minus 1. So we get 2 times, -4 to the 6, which should be 4,096. So the 7th term is just 8,192. All right, so now you practice. Try to find the indicated term. So we have the 11th term here, the 8th term, the 12th term. Okay, now I'm going to go through it. The ratio for 10 is 2. So the nth term is 7 times 2 to the n minus 1. So we want to find a sub 11, which is 7 times 2 to the 11 minus 1. So 7 times 2 to the 10th, that does not look like minus 1, equals, let's see, I would get out the calculator. That's 7,168. 11, we have our ratio is 60 over 100, so we get 3/5. So our nth term is 100 times 3/5 to the n minus 1. We want to find the 8th term. So 100 times 3/5, 8 minus 1. Oh, okay, sorry, I got myself turned around. Okay, so here we get 100, and then we would do 3 to the 7th and 5 to the 7th. So that's 3 to the 7th and 5 to the 7th. So 100 times 2187 all over 78125. You put that in the calculator, I would let that reduce it. So you get 972 out of 125. Well, that doesn't seem... Oh, yeah, because the bottom number is smaller because we multiplied the top number by 100. Silly. Well, silly me. I didn't think that through. All right. If you have questions, ask me in class. Be happy to go through the technicalities if you forgot how to use your calculator or you got a new calculator. All right, number 12, we have r equals, well, I don't want to deal with fractions, so I'm going to do these numbers. 2 divided by -1 is just -2. So our nth term is -1/4 times -2 to the n minus 1. Plug in your stuff. -1/4, -2, 12 minus 1. So -1/4, -2 to the 11th would be -2048. Don't rely on that negative for your calculator. Your calculator likes to do it differently. Well, it likes to follow the rules, right? That PEMDAS, so be careful. And then, let's see, so that you plug that in your calculator, you should get 512. All right, so now what do we do from here? We want to find the nth term. Okay, so sometimes it helps to visualize it. So if we've got 10 is our fourth term, well, we want to find n when n is 5. So that's our fourth term. The fifth term is right after it. And remember, this one is r, so we're doing geometric, we're multiplying. So to go from 10 to the fifth term, or the next term, you would just do 10 times r. So 10 times a half is just 5. So the fifth term is 5. Okay. Number 14, we have the third term, but then now we're looking for the ninth term. So you could sit here and count it all out, right? That's the third term, and then do all your boxes. All right, or your lines. I don't know why I said boxes. And then figure out the ninth term, or use your formula. A sub 9 equals, well, I guess I should do the generic form first. Okay, we already know the first term is well, let's see. Well, we could go the other way. I'm trying to think. There's a lot of different ways to go about this. Sorry, and the kids in my last year, they did it a little differently. So let's see. Since the ratio is -3, that means you're multiplying it every time, which means if you're going in that direction, you're going to divide by -3. So since we're close, we could just figure out the second term and get divide by -3, so we get what is that? -21, and then divide by -3 again, and that gets us 7. So we could do that way to get our first term. Then our ratio is -3. Since it's the ninth term we're looking for, n is 9. So we want to find the ninth term. All right, we knock that out. We should get 45,927. Okay. Hopefully that makes sense. If not, just ask me. All right, I might have a different way of looking at it. Okay, so we talked about arithmetic means, where the numbers in between non-consecutive terms. Well, we can also have geometric means. So between 3 and 768, there are 3 geometric means between them. Okay, so the numbers between. Ooh, I don't know why I lost the line there. Okay, so how do we figure this out? I do it very similarly how I do the arithmetic means. Okay, but now you're just doing ratios. So we take the number 25 and we're going to multiply it by 1r, 2 r's, 3, 4, 5 r's. So 1, 2, 3, 4, 5 r's. And that's going to get us that last term there, 32 over 125. So what we have is 25 times r to the 5th power equals 32 over 125. So we can divide by 25. So r to the 5th equals 32 divided by 125. And then we divide by 25 or multiply by 1 over 25. Okay, we could do that. That's perfectly fine. We multiply, or we get that, and we get r to the 5th power equals 32 over 3,125. So to get rid of the 5 there, we need to take the 5th root. So we do that, we get r on the left side, and then now we just plug in our calculator, the 5th root of 32 over the 5th root of 3,125. So we end up with 2 over 5. Okay? Let's keep doing it. Okay? I get a lot of people with questions on this. Okay, so number 16. We have 2, and we're going to multiply it by 1, 2, 3 r's, so r cubed, to get us 54. So r cubed is 27. When we take the cube root of everything, we get r equals 3. So our ratio is 3. I just realized I solved for the ratio. That's not what I was doing here. Okay, that was not the point of this question, or to erase it, or, oh goodness, all over the place. Okay, so the ratio is 2/5, so keep multiplying. Okay, now we got to use it. Take 25 and multiply by 2 out of 5. That gets you 50 out of 5, or 10. Multiply your 10 by 2/5. That gets you 20 out of 5. Okay, so we end up with 4. Multiply another 2/5, you get 8/5. Then 16 over 25, 32 over 125. Now to go in the other direction, we need to divide. So 25 divided by 2/5 is really 25 times 5 over 2, which is 125 over 2. So instead of multiplying by 2/5, you're now dividing by 2/5, which is multiplying by the reciprocal. All right, that keep, change, flip. We do it again, and the first term is actually 625 over 4. So a little trickier. Okay, back to 16. So you had, the ratio is 3, so we multiply it here. So to go in that direction, you're going to multiply by 3. To go in that direction, you're going to divide by 3. So 2 times 3 is 6. 6 times 3 is 18. 18 times 3 is 54. All right, so that ended up good. Go the opposite direction. 2 divided by 3. Divide by another 3, you get 2 over 9. Let's do it again. 32. There is, count them up, 4 jumps, so r to the 4th equals 162. You divide by 32. So you get r to the 4th equals 162 over 32. Kind of gross. I'm going to reduce it. 81 over 16. Well, that's a lot easier to notice, right? R to the 4th power. Well, r just needs to be 3 over 2, because 3 to the 4th power is 81. 2 to the 4th power is 16. So we just multiply along. You should get 48, 72, and 108. Got any questions? Ask me in class. Be happy to go over it some more. I know these get a little weird.